Hey kiddos, hope you're having a good day today. It's December 1st when I'm making this video, December 2nd when you're watching it. So I'm going to be festive every single day. I got a fun little Christmas hat on today, and then my shirt says fabulous. Get it? I wasn't going to break out the other Christmas sweaters this early, but it was so cold outside that I had to. So one of the only Coyote standards that we've covered it a lot of times in class, but we haven't actually spent some time practicing it, is going to be word problems. So these are the questions on the Coyote that are about like the quarters and dimes and the ones about napkins, stuff like that. So these aren't the ones about quarters and dimes and napkins, but these are very, very similar to the ones on the Coyote. So we're going to do some practice with that today. So I'm going to do most of the work on the screen. It'll just be easier that way. So you need to make sure that you're listening to what I am saying. Please and thank you. So this says, Parker owns a food truck that sells tacos and burritos. He sells each taco for $3.25 and each burrito for $7. Yesterday, Parker made a total of $552 in revenue from all the burritos and taco sales, and there were twice as many burritos sold as there were tacos sold. Write a system of equations that could be used to determine the number of tacos sold and the number of burritos sold. Define the variables that you use to write the system. So for this first part of our assignment, we're just writing the system. We're not worrying about solving it. So I recommend starting with highlighting what's important. So he sells tacos and burritos. That's important. Each taco costs this much, and each burrito costs this much. He made a total of 552, and there were twice as many burritos sold as there were tacos sold. So I think that is pretty important, all the stuff I highlighted. So we're dealing with tacos and burritos. Tacos and burritos are going to be our two variables that we're defining. So we're going to let T be the number of tacos sold, because that's what we're trying to find. It literally says that down here at the bottom. And we will let B be the number of burritos sold. So we have two variables. We're going to have two equations. So we know, let's deal with the money first. We know that each taco costs $3.25. So if I wanted to find the price of 3 tacos, I would do $3.25 times 3. I think all of you can tell me that. So I'd write that by doing 3.25 T for tacos. And then I also know that a burrito costs $7. So that's going to be plus 7B. And that is going to equal my total of $552. That's going to be one of my equations. So that takes out this important information, that one, we already did that one. So what we're left with is twice as many burritos sold as there were tacos. So this, I just did this lesson in my Algebra 2 class. This is where kids get mixed up. So you have to read carefully what it's saying. There were twice as many burritos sold as there were tacos. So I have more burritos. I sold more burritos. So whatever you sold more of, that's what it's always going to be equal to. So it's going to be B equals, and there were twice as many burritos sold as there were tacos sold. So twice means 2 times, so 2T. So if you want to double check and think, oh, does that make sense? If I had 5 tacos, this equation gives me 10 burritos. So that does make sense in terms of our problem. So we're going to go ahead and submit that. We're going to see what it says. And yeah, we were right. So we'll do another one like that. Show question. Nope, show question. Good. And I want to wipe the screen clear. Well, look at how fancy these tools are. Okay. So this one, Madison has set up a lemonade stand outside her house and sells small cups and large cups of lemonade. Each small cup holds 12 ounces of lemonade. Each large cup holds 22 ounces of lemonade. Madison used 1,240 ounces of lemonade and sold 10 more large cups and small cups. I have to sneeze, excuse me. Oh man, you kidding me? That's embarrassing. Okay. Madison used 1,240 ounces of lemonade. There it is, a little late. and sold 10 more large cups and small cups. Write a system to determine the number of small cups and large cups sold. So again, we're going to get out our highlighting tool. We're dealing with small cups of lemonade and large cups of lemonade. Each small cup holds 12 ounces. Large is going to hold 22 ounces. And she used a total of this much. And she sold 10 more large cups than small cups. Okay. So we're dealing with small cups and large cups. So we're going to let S be for the number of small cups. And we're going to let L be the number of large cups. And I'm going to make my two systems. So I'm going to start with ounces. So I have how many ounces a small cup has, how many ounces a large cup has, and how many ounces she used total. So a small cup holds 12 ounces, so 12S plus a large cup holds 22 ounces, 22L, that's the one, 22L is going to equal the total 1,240 ounces. And then, so we already used the top three things. All we're left with is 10 more large cups than small cups. So remember, we have more large cups, so it's going to be L equals 10 more. That means if I sold 20, I'm going to sell 30. So that we're going to be adding. So it's going to be 10 plus S. So if you need to check that one, if I sold 10 small cups, that means I sold 20 large cups, and that is what my problem is asking for. So I'm going to submit this, see if that's correct. It should be. Good, perfect. So now the second part of your assignment is going to be solving these systems. So I will set up the problem on the screen, and then I'm going to switch to do it on paper. So there might be an awkward pause, but we'll start it up here. So Aria is a songwriter who collects royalties on her songs whenever they are played in a commercial or a movie. Aria will earn $20 every time one of her songs is played in a commercial, and she will earn $80 every time one of her songs is played in a movie. Aria earned a total of $400 in royalties on 11 commercials and movies. Determine the number of commercials and the number of movies on which Aria's songs were played. Sorry, I need a drink. Look at this cute festive Christmas cup that has the Grinch on it. We're festive in room 40. Okay, so this one doesn't ask us to define our variables and anything, but we are going to have to do that in order to solve this. So we're going to go through and we're going to highlight what's important. So we're dealing with $20 every time one of her songs is played, $80 every time one of her songs is played in a movie. Oh, I'm sorry. This should continue in a commercial. She's made $400 on 11 commercials and movies. Determine the number of commercials and movies in which her songs were played. So we're going to let C be commercials. And then we're going to let M be movies. Wow, it's so hard to write with a mouse. So C is going to be commercials and M is going to be movies. So we know she'll earn $20 every time one of her songs is played in a commercial. So that's going to be 20C. And she'll earn $80 every time it's played in a movie. So plus 80M is equal to $400. So that's how much she made total. So you're always going to want your equations to be in like the same units, like 20 is money, 80 is money, 400 is money. You're not going to want to mix stuff up that's like money and amount of times played and stuff like that. So we've done that, and then it tells us she made $400 in royalties on 11 commercials and movies. So that means 11 combinations. So if you added the total number of commercials and the total number of movies together, you're going to get 11. So we're going to have our commercials plus our movies is going to equal 11. So take a second to get that jotted down while I switch over to my document camera here. 20C plus 80M equals 400. And then we have C plus M equals 11. All right, let's switch over here and do some math. So we're going to open the Ladybug. Oh, that's so blurry. Okay. Wait, I want to see my dog. Where's she at? Oh, there's my dog. Hi, London. Okay. 20C plus 80M equals 400, and C plus M equals 11. So this is where what we did a week or so ago comes into play. We're going to have to use substitution or elimination on these. So most of the time, you're going to want to use substitution because I think it's easier for us to do. So for substitution, you have to get one variable by itself. So I'm going to solve for C. So I'm going to go ahead and minus M from both sides. So C is going to equal 11 minus M. And like what we did last week, we're going to plug this in wherever we see a C in that first equation. So it's going to be 20 times 11 minus M plus 80M equals 400. So then we're going to solve. So we're going to distribute that 20. So it's going to be 20 times 11 is 220 minus 20M plus 80M equals 400. Combine like terms, 220 plus 60M equals 400. We're going to subtract that 220 over. So 60M is going to equal 180. We're going to divide by 60. So M is going to equal 3. So since I know what M equals, I'm able to plug that back into either one of these equations. The second one is going to be easier. So C plus 3 equals 11. And then I'm going to subtract 3 from both sides. So that's going to give me 8. So C is 8, M is 3. So if I hop back over to my Delta Math, songs were played on C was for commercials, so 8 and 3 movies, and we're going to submit that. And yeah, we got it right. So that is what we're going to be working on probably today and tomorrow, is doing word problems. So as always, I'm in the Google Meet if you have any questions. I know we struggle with word problems, so feel free to come and talk to me and we can do some together. As well as always, check your grades, get missing assignments turned in, all that jazz. I'm here to help. If I can do anything at all to help you, please let me know. But if I don't talk to you again, have a great Wednesday, and I'll talk to you soon. Bye.